Hello, my name's Kathy Kellenberger, and I am co-leader of the Women in Technology virtual group at PASS. Tonight we have a session, but first I want to tell you a little bit what's going on in our chapter. First of all, we are all about encouraging each other, empowering each other to help each other have great careers in technology. And our webinars, we generally feature women speakers, but not always. And we're all about helping each other develop our careers and also building friendships in this field. We are very pleased that SentryOne is our sponsor, and tonight we will be giving away a gift card to one of our attendees. I have written down a number, and the person in that position in our attendee list, I will choose that person, and in the chat I'll let you know whether you've won or not. And then if you have won, you'll get an email from PASS telling you how you can get your gift card. So thanks to SentryOne for their support, not only for our chapter, but also for our Women in Technology lunch at the SQL PASS Summit. You can find recordings of all our sessions out on our YouTube channel. You can also find links to those on our homepage at wit.sqlpass.org, as well as links to register for future webinars, lots of other information about our group, and we also have a monthly newsletter that goes out. You can also follow us on Twitter. This month we've actually been featuring new speakers, New Year for new speakers. In March, to celebrate International Women's Month, we'll have sessions from 4 highly rated speakers in the SQL community: Erin Stellato, Wendy Pastrick, Kaylin Delaney, and Ree Irish. So I hope you will join us for those sessions. We also like to promote women in the SQL community speaking at events such as SQL Saturdays. So we have several SQL Saturdays coming up this weekend in Cleveland. I'm actually one of the speakers there, which is kind of fun. And we've got another one we're promoting here in Melbourne. We have a list of all the SQL Saturdays on our site, so be sure to check that out. And we also have the webinars. Not only do we have our own webinars that we put on, but we also like to promote webinars by some of the women speakers for some of the other groups. So Erin and Kimberly are both speaking at a couple of the other groups, but we would like to promote that as well. So be sure to check those out. You can find the links to those on our site if you want to go out there. So tonight we will be learning a bit about Oracle SQL and PL SQL from Ashwina Dodiani, and the reason for this session is because most of us in PASS, most of the members of this group, work with SQL Server. However, rarely do we work with one database platform throughout our careers. I have occasionally myself worked with Oracle, so Ashwina is going to teach us a bit about the differences between Oracle and T-SQL. Ashwina is a techno-functional business system analyst with notable success in working with a broad range of IT projects. She possesses strong analytical skills and hands-on experience with Oracle SQL in developing reporting solutions, analyzing data, and designing complex data models. And my favorite thing about Ashwina is that she is also a member with the Launch Code organization in St. Louis, and we work together teaching a group of about 24 women right now. Anyway, we're teaching them about databases, SQL Server, Oracle, MySQL. We're teaching all of them about that over the next few months. So I'm really proud to work with her on that project, or on that class. So I'm going to turn it over to Ashwina. I'm going to unmute her and make her a presenter.
Thanks, Kathy.
Thank you very much.
Hello, everyone. My name is Ashwina Dodiani. I'm a business systems analyst at a supply chain solutions and value-added reseller organization in St. Louis. I have a bachelor's and a master's degree in computer science. I was introduced to SQL and database management as part of my courses in school. I started writing SQL for reporting, data analysis, and automation when I first got hired as a business analyst. I've continued to use SQL and PL SQL in the past 8 years as a business analyst to perform automation, integrations, data conversion, data analysis, etc., in addition to other job functions that are not related to SQL. I also have experience in creating and working with data models. All of my experience is related to Oracle. I will be happy to answer any questions related to my experience or bio at the end during the Q&A. With that, I'd like to begin the presentation. The first few slides that I have are very basic that apply to almost all database languages, if not all, most of them. So the first slide I have here is very basic on what kind of database languages are out there. At a very high level, right, a database language is nothing but a query language or a data manipulation language. So these are some examples of popular query languages that are out there. PL SQL being the procedural extension that Oracle developed for SQL. T-SQL, which most of you might be familiar with, it's supported by Microsoft SQL Server and Sybase's SQL Server. SQL PL stands for Structured Query Language, Procedural Language, and was developed by IBM. Whatcom SQL, it's a dialect of SQL that's supported by SQL Anywhere. And SQL Anywhere is a relational database management system which is a product of SAP. Here I wanted to highlight a few examples of basic SQL statements. SQL statements are not just limited to these, but these are a few key important examples that are used every day with query languages. So data definition language is what defines the structure of an object in the database, such as create, alter, and delete. So these are examples of a DDL statement. Create table, for instance, would create an object of type table in the database. You would create it with the columns that you want to define in that table. You would provide the data type for those columns, and then you would provide the size for those columns when you're creating that object. A DML statement is used to access and manipulate data in existing database objects. So update, delete statements would be examples of DML statements. For instance, here I have the syntax for how an Oracle update statement looks like. So if you wanted to update certain columns on a table, for instance, you would run your query in the syntax, and your where clause will limit the data that you want to update in the database. A transaction control statement is what will commit or revert your changes from your DML statement. So for instance, if you issued a delete statement against a table and you did not want to commit your changes, then you could use rollback to undo your changes. But if you wanted to commit a DML statement, so for instance, if you ran an update statement and you wanted to commit that, then the commit command will do exactly that. Now what I have here is a little bit of focus on Oracle's products and services. So Oracle is a big organization and they have a lot of products and services. What I have here is more relevant to the presentation that I'm giving here. So Oracle ERP is an enterprise resource planning product that Oracle provides. It contains a range of modules that are integrated with each other. It's an application that a lot of enterprises use. There are other ERP solutions out there as well besides Oracle ERP. But the modules that I've mentioned here are some examples of the modules that come with that ERP system, or that e-business suite is what Oracle calls it too. These are all integrated with each other. And how this is relevant to this presentation is Oracle has built a lot of these modules based on PL SQL. So the back-end code for a lot of these modules, or for their entire e-business suite application, is based on PL SQL. Oracle obviously also has a database as a product. So here I've outlined at a high level differences between SQL and PL SQL. So SQL can be executed one statement or one command at a time. PL SQL is a programming unit. So it's a block of code that you can write as one program. You can have DDL, DML, and TCL commands, both in SQL and PL SQL. You can manage database security using SQL as well. The difference with PL SQL is that you can perform conditional processing. So for instance, you can use if then else conditions. You can use loops using PL SQL. You can write case statements. You can do exception handling, which is also error handling. Therefore, SQL is a non-procedural language and PL SQL is a procedural language. This shows at a high level how Oracle's PL SQL engine works. So when an application calls a stored procedure or a package in the database, what Oracle does is it loads the compiled package or procedure into the shared pool in the SGA, and the PL SQL and SQL statement executors work together to process these statements within the procedure. So you have the database, you have the database application that's calling the procedure inside of the database, and then you have Oracle Server, within which you have the SGA, you have the statement executors for both the PL SQL engine and the SQL statement executor. So PL SQL has what is called anonymous block. What that means is if you want to write a program, a piece of code that you want to run just one time, and you do not want to store it in any database, then you can use a query tool to do just that, and it's not going to be stored anywhere. Whereas a name block is a stored procedure, for instance, which is a PL SQL block of code that Oracle stores in the database, and it has its own name. The purpose of that name would be to use it from any application that connects to the database. So it would call a procedure by its name. There are three different kinds of name blocks within PL SQL. There are procedures, functions, and packages. Packages are simply a collection of procedures and functions. Procedures are not expected to return a value, so that's the key difference between procedures and functions. Functions are always expected to return a value. Like I said, the advantage of using name blocks is that if the same piece of logic has to be used in multiple places within a single application or even across applications, then it helps to reduce redundancy, since you can call the same name block from anywhere and you don't have to repeat writing that piece of code again and again in different places. Now, once a PL SQL name block is compiled, it can be run anytime after that. But every name block that is stored in the database that is going to be used has to be compiled before it can be called from anywhere. Syntax errors are what are errors that are generated at the time of compiling that object. And that object cannot be compiled until all syntax errors are resolved. So an example of a syntax error would be if you misspelled a reserved keyword, then that's an example of a syntax error that you would get when you're trying to compile a PL SQL block. Whereas runtime errors are errors that are generated at the time that you're running that programming block. And they're related to the logic of the code in that PL SQL program block. Now this is at a high level what a structure of a PL SQL block looks like. So the first section is the declaration section, where you have your variables defined, your constants defined, your initialization for your variables. Then the second section is the actual logic, the program body of that program. And the third section is the exception handling section, where you handle your error conditions. Now, PL SQL allows you to explicitly handle both internal and user-defined error conditions called exceptions that arise during the processing of that code. Internal exceptions are what are caused by illegal operations, for instance. So divide by 0 would be an example, or Oracle errors that are returned to the PL SQL code. But user-defined exceptions are explicitly defined and signaled within the PL SQL block to control the processing of errors that are specific to the logic of that program or of that application for which you're writing that program for. I wanted to highlight some key uses of Oracle PL SQL that I have seen. There are many more that are out there, but I wanted to put the ones here that I have used personally. So the first one is, I'm sure, pretty obvious to everyone, right? Querying the database from application. And this goes back to the name blocks, for instance. So you would define your program blocks within the database. You would give them the names, and then those are called from different applications that connect to the database. So that would be one way of how you would query data from the database. Reporting is another obvious one, I think. So this is used widely to extract data from the database and make it meaningful to your users. Automation and building applications. So this is where the example of using the Oracle EBS modules, like I was saying earlier, that are based on PL SQL. So a lot of customers that use the Oracle ERP system, or a lot of organizations that use the Oracle EBS system, they extend their modules using PL SQL code because that's what Oracle's written the original code in as well. The next one here is the business-to-business or application-to-application integrations. So the logic for the integrations could be performed in PL SQL, such as collecting data that's relevant to the integrations in a staging table. Then you can apply additional conditions to transform that data before you're going to go transmit that data to a partner or to an application. You could build APIs in PL SQL just like you could with any other programming language. You can also use it for data conversion validations. So if you're migrating your data from one system to another system or one platform to another platform, then PL SQL can be used to write those conversion scripts. And you can also perform data validations to compare the integrity of the data pre and post conversion. So moving on to what are the differences between Microsoft SQL Server and Oracle. These are, again, high-level differences. There are more differences, but I wanted to highlight some key differences. So obviously, like I've said, the language that's used with the two databases is different. So with Microsoft SQL Server, T-SQL is the language that's used, and with Oracle, PL SQL is the language that's used. I wanted to talk about transaction management also, because I think that's also a differentiator between the two. So transaction is a group of operations or tasks that should be treated as a single unit. For example, if you had a list of update statements where if one of your updates failed, you do not want any other statements to be committed to the database. So that is an example of a transaction. By default, T-SQL will execute and commit each command or each statement individually, unless if you use begin and commit transaction commands, in which case T-SQL will group those together as an explicit transaction. And then those statements, if one statement fails, then it fails the entire execution of that block. But if all of the statements succeed, then it's going to commit everything that the transaction is doing to the database. Whereas with PL SQL, with Oracle, a transaction begins when it encounters the first executable SQL statement. Now, if you have a series of queries that have to be run as a transaction, Oracle makes changes in memory only until the commit command is issued. After the commit is issued, the next command then is treated as a new transaction and the process begins again with Oracle. So with T-SQL, if errors are encountered, then all the data modifications that are made after the begin transaction can be rolled back to return the data to its known state of consistency. And each transaction lasts until it either completes without errors and commit transaction is issued to make the modifications permanent to the database, or errors are encountered and all modifications are rolled back with a rollback transaction statement. With Oracle, a transaction can also end if one of these things happen. So if it encounters an issue command or rollback, then the transaction ends at that point. Or after it's run the transaction statements, if it encounters a DDL statement, then the previous transaction ends at that point. If a user disconnects from Oracle, then Oracle will save the current or commit the current transaction. If a user process terminates abnormally, then Oracle will roll back the current transaction. So this is an example of a transaction, right? So if a bank user wanted to transfer, for instance, $500 from their savings account into their checking account, then all of these transactions have to happen as a single unit. The first update statement would decrease their savings account balance by $500. The second update statement would increase their checking account balance by $500. The last insert statement would insert a new journal entry. So if the first update statement failed or the second update statement failed, you would not want to commit that transaction. So this, I wanted to use this as an example of what I mean by a transaction. Now with Oracle, when a transaction begins, it assigns that transaction to a rollback segment to record the rollback entries. And it also generates redo log entries in the redo log buffers. These are, again, some high-level differences between SQL Server and Oracle. So they're different in how they deal with data types, locking, data storage, their operators. Built-in functions can be different between the two. Other functions such as date functions or mathematical functions. So these are some examples that I wanted to provide. So for instance, with data storage, with T-SQL, or with SQL Server, I'm sorry, these are logical devices assigned to store the log. And the database device to store the logs can be specified while creating the database. Versus with Oracle, each database has a set of 2 or more redo log files. So all changes made to the database are recorded in the redo log files. And Oracle also allows you to mirror redo log files so that you can maintain 2 or 3 copies of the redo logs. Now moving on to the actual differences in languages. So differences between T-SQL and PL SQL. So one thing that's important is I think both of them can perform the same functions. But there are differences in syntax, for instance, or there are differences in how they handle variables, or how stored procedures are written, or there are differences in built-in functions, for instance. One difference that I had talked about earlier is PL SQL has packages where you can group procedures and functions into a single package. Some examples of built-in functions that are different in the two languages. So if you wanted to retrieve the current date and timestamp, you would use the getDate function with T-SQL. And with PL SQL, Oracle SQL, you can use, or you use the sysdate function. The length function also happens to be different. So with T-SQL, it's len. With Oracle SQL, it's length. The data type conversion built-in functions are also different, and we'll look at examples in the next slide. And the null value function, where if there is a column that is null and you want it to use a different value instead of null value, then in case of T-SQL, you use isNull function, whereas with Oracle SQL, the function is NVL. So here I wanted to provide some examples of SQL built-in functions, some of which I was talking about in the previous slide. So the toChar function is a conversion, data type conversion function. And we will run these queries in a minute to show you how this function works. The substring function returns So if you have a character string and you want it to return part of the character string starting at a certain position, then you can use the substring function in PL SQL. The inString function is used to search a certain character string for a substring, and you can specify the position where you want to start the search and the occurrence. So you can tell what occurrence you want to bring back. For instance, if the substring that you're searching for has more than one occurrence in the string that you're searching in, then you can tell the function which occurrence you want to return back, and the result of that function will be the position that it finds your substring. The RPAD function, like you can see from the syntax, it has expression 1, then the length, and expression 2, which means what it does is it will write pad the first expression with the second expression as many times as necessary until it finds or it stops at the length that is mentioned by the second parameter. So let's quickly run through these examples here. So like I said, sysdate in Oracle will return the current date and time. So this shows both the date and the timestamp. Now, if I wanted to do a conversion to bring it back in a different format. So in this case, I'm saying bring back the current date in the format of the year followed by month and date. Then it's going to return in that format that is given in the second parameter there. Whereas if I wanted to switch it now again and bring it back in a different format, which is going to bring back the date with the date spelled out with characters. So in this case, it's going to say 2017 January Tuesday, because I'm returning day in this case. Now if I had to run this statement, I'm simply returning 1, 2, 3, 4 as my number, right? Now what I'm saying with the next statement is I want to change the format of my output here. So I want it to return with a $ and decimal points and a comma. So that's exactly what the toChar function will do, and it will return in that format. The very last example here, again, is doing the same thing, and it's converting that number into a format and returns it with decimal places. The next one that we looked at was substring. So in this case, my character string is PL SQL, and the two words have a space in between. And I'm asking it to return part of the string that starts at position 4. So in this case, it should return SQL. So if I run the statement, it returns SQL. The next function that we looked at was inString. So in this case, the first parameter is the actual string. The second parameter is the substring that I'm searching for. The third parameter is the position. So it's going to start searching at position 1. And the fourth parameter is the occurrence. So I'm telling it search for the very first occurrence. So this should return the position at which it finds substring PL SQL. So in this case, it's position 25. The next example here is RPAD function. So here I'm saying My first expression is no lemon. My second expression is no melon. I'm saying right pad the second expression to the first expression and stop when the total length of the character string is 21. So this is the result that it comes back with. So moving on from built-in functions to views. A view is a logical table. It represents one or more tables in the database. So the tables that the view uses are called base tables. Views can also be based on other views, so they don't have to be just based on tables. And views are powerful since they don't occupy any physical space, but they can be treated just like tables. The operations that are performed on a view can also affect the base tables. So for instance, if you're performing a DML operation on a view, then that impacts the base tables as well that the view is using. So here's an example of a view where we're joining an employee table to a department table based on the department number column. We're returning employee number, employee name, and salary from the employee table, and then department number, department name, and location from the department table. So if we wanted to query data from the employee table and the department table before this view was created, right, we would have to write a query similar to the one shown here. And you would have to, every time you had to query those two tables together, you would have to write that query. But after you've created a view on those tables, then you can simply write your query against the view, and the statement becomes much more simple. Now we assume that most of the time you want to query data that's related to a certain department. So for instance, you deal with accounts department a lot, and you want to create a view that only brings back records from the accounts department, then this is how you could do that. So in the where clause of the view, you can give the department number and limit it to one department. Notice that I've used a with check option constraint here. So what that does is it creates the view with the constraint that any insert and update statements that are issued against this view are not allowed to create or result in rows that the views cannot select. So that's the use of the with check option constraint. So now once this view is created, then like I said, if you wanted to query data for that department, you could simply write statements against that view. So you could sum the salary of all employees that work in that accounts department. Or you could bring back the highest salary from that entire department. So there's a lot that you can do once that view is created against those base tables. Now, here's an example of what would be a valid DML statement against that view and what would be an invalid statement. So in this case, we're inserting into that view values, employee number, employee name, and department number. So the reason that the first insert statement is valid is because the department number is 10. But the second statement is invalid because we're inserting with department number 30, and this view has a check constraint, and there is a where clause that limits it to department number 10 only. So in this case, it will return an error and this DML statement will be rolled back. You can also create a view without defining a query within the view. You can do that using force view option. So, for instance, if the view refers to a non-existent table in the database or an invalid column in an existing table, you can still go ahead and define that view using this force view option. When this kind of a view is created, Oracle leaves the status of that view as invalid. But if you go back to the view and modify the query in the view such that the query is now valid, then the view can be recompiled and it becomes valid. This shows options of how you can change the definition of a view. So there are two options of changing the definition of a view. The first option is you could drop and recreate, which means that all grants and privileges that are on that view are lost when you do a drop. The second option is you can use create or replace in the view definition, which preserves the grants and privileges. So here's an example of create or replace view. I've used the example that I used a couple of slides back with the accounts department, but notice that I've changed the department number to 30. So if you define the view with a certain where clause, you wanted to change the query and change the where clause, then you can replace the view definition this way. But if you decided that you wanted to drop and recreate the view completely, then you can use the drop view statement. Now, if you do not want any DML operations to be performed on your view, then you can create it with read-only option, in which case Oracle will not allow any DML operations to be executed against that view. Otherwise, there are certain criteria that apply for when you cannot write a DML statement against a view. So if a view is defined by a query that contains, for instance, a set or a distinct operator, or a group by clause, or a group by function, then rows cannot be inserted into, updated in, or deleted from the base tables used by the view. Then, like we saw earlier, if you use with check option, then you cannot insert into or update a row in the base table if the view cannot select the row from the base table. So the insert statement that we saw earlier, that would have been invalid if you use the wrong department number. Another condition is if your view uses a not null column that has a default clause which is omitted from the view, then a row cannot be inserted into the base table using the view. Also, if the view is created by using an expression such as decode, for instance, so if you wanted to decode your department number of 10 to accounts, then if you use the decode function in the definition of the view, then Oracle does not allow you to insert or update in the base tables using the view. So those are restrictions on the DML operations against a view. Now, I wanted to go over more examples of what DML operations are allowed and which ones are not allowed. So I wanted to start with join view. So that's what we've been seeing examples of so far, is when a view involves one single join or multiple joins. And there is what is called a key preserved table in a view. And a table is called key preserved if every key of the table can also be a key of the result of the data that is returned from the view. So for example, with the employee department view, the employee table is key preserved because every single row that will be returned from this view returns a unique row from the employee table. Whereas the department table is not key preserved because there will be multiple rows returned per department because you'll have multiple employees assigned to a single department. So what this shows is what cases is an update allowed in Oracle against a join view. These are just a couple of examples that I used. So the first example, for instance, what this statement is doing is it's updating the salary column in the employee department view. This is allowed because, like I said, the employee table is a key preserved table. So Oracle will allow an update against the employee table column. But the second example is not allowed because it's trying to update the location column, which belongs to the department table, which is not key preserved in this view. So the next examples are against delete statements. So the first delete statement is allowed because it translates to a delete operation on the base table, and employee table is the only key preserved table in the view. So then it allows this delete operation because it knows exactly what row it needs to go and delete. In the second example, this delete is not allowed because there is more than one key preserved table in the view. So a delete against such a view would not be allowed. In the third example, a delete would not be allowed against this view because it involves a self-join of a table that is key preserved. And this very last example shows what kind of inserts are allowed. So again, in the first case, this insert statement is allowed. The assumption here is that your employee department table has a where clause for department number equals 40. So the first statement is allowed because it's respecting the foreign key constraint, because it's going and inserting with department number 40. But the second statement is not allowed because it's violating the foreign key constraint. Department number 77 in this case is not valid. Now, if you're working in Oracle and you wanted to go and look at what columns in a view are updatable and what columns are not, then you can simply run the select statement against user updatable columns and give your view name in the where clause, and it will tell you which columns are updatable and which columns are not updatable. With that, I am at the end of my presentation. Just wanted to highlight really quick on where I got my references for examples or for the content for this presentation. It was all from Oracle's knowledge base. I think with that we can go to the Q&A.
Okay, thanks, Ashwina. If you send me the slide deck, I can upload that, and I will also have a link to the recording on our site. Right now, I don't see any questions, so if any of you would like to write a question, ask Ashwina a question, please enter it in the question box. And I also have sent a chat message to one of you online. Please check to see if the little pink chat notification is lit up, because one of you has won a gift card, and I haven't gotten a response back. So we'll wait for a minute or so to see if we get any response on the questions. So that one thing that was really interesting to me was on that last slide where you have that user updatable columns. That is pretty cool, because otherwise, you know, I know in updating views in T-SQL, I generally discourage that, because there are, just like in Oracle, there are so many things, you know, so many things you have to take into account, especially if that view has all the columns that it should have, or if it's you know, a join in there. So there's so many requirements, but maybe I'm wrong. Could be wrong.
No,
So I just have it run across. Yeah, but we don't have that user updatable columns. I guess you'd call that kind of like a system view. That, as far as I know, I could be wrong about that, but so that is pretty cool.
Yeah, and I completely agree with you, Kathy, on, you know, in general, you don't want to run any DML operations against views. It's not advisable, even with Oracle. But if you must, for some reason, then yes, that's a pretty cool way of quickly looking at what columns are updatable.
Right. And there's so many system views, you know, data, we call them data management objects, data management views, system views. There's so many of those to learn in SQL Server. I'm sure it's the same way in Oracle. So, but that is a pretty neat one right there. I am still not seeing questions. We had quite a few people on the session. Oh, wait a minute, I do see a question. Let me undock the pane so I can see it. Could you please provide an example on B2B/A to A build API, how Oracle is being used? So does that sound like something? Okay, go ahead.
Yeah, I can provide an example of where I have used it, for instance. So like I said in my introduction, I work in a supply chain domain. And so where we've used it is we have integrations with our suppliers, for instance. So we place our purchase orders with our suppliers, and we have integrations to do that. So we have EDI integrations with our suppliers to do that. So what we do is we might have, you know, hundreds of different suppliers, and each supplier might have a different requirement of what they want us to transmit to them, what data they want us to transmit to them. So what we do is we go against all of our purchase order data, for instance. We collect it for that supplier, and we will put it in a staging table. But when we do that, we also create a package for that supplier. And within that package, we have logic that says, this is what this is the data that the supplier cares for. So put X in attribute 20 of this staging table for this supplier. Now, there might be also times where we have to translate. So a piece of data might mean something to our organization, and it might mean something else to the supplier. So you have to perform that translation somewhere before you transmit that data to the supplier. So that translation logic can also be put within that stored procedure or that package before you load the staging table. Then once this, so that package, right, that I'm talking about where you perform all of that logic, we've used PL SQL in almost all of our integrations to do that. So does that answer the question?
He's got a follow-up, he or she, I'm not sure, has got a follow-up question for automation and building applications. Is Oracle used directly, or is it consumed by other services and other applications like Cucumber, etc.? But it sounds like you're using PL SQL directly is what it sounded to me.
Yes, so we are using PL SQL directly. And so one example that I obviously use in this presentation is that Oracle's EBS modules are based off PL SQL. So they have these user interface forms, for instance, right? So they have a sales order form. They built it a certain way, a standard way for all of their customers, right? They're not going to change it for every single customer. But we have the option of extending that user interface or that form or the logic in some cases behind that form to use it the way that we want to use it, right? So to extend that logic, we either build on top of what Oracle already has on that form, or we might do what we call a form personalization on top of that form. So how that works is you have the Oracle code that gets executed, and then on top of that, it executes the additional PL SQL code that we've written that's meaningful to our organization.
Cool. And they said, yes, thanks for answering the first question, so that was good. I have another question. I see you were using Toad. Have you used SQL Developer for Oracle? Are there coding templates for your packages?
So I have not used SQL Developer. I've only used Toad, which from what I understand, I have some peers that use SQL Developer at work, and from what I understand, they're pretty similar in the way that they work. I think SQL Developer is a little more restricted than Toad is. What was the, I'm sorry, I didn't catch the second part of the question.
Are there coding templates for your packages?
We don't have templates per se, I don't think, but we have coding standards that we follow, if that's what you're getting at with the templates.
Okay, if she wants to ask or clarify the question, we can wait for that. So this has been pretty interesting. Again, you know, most of our viewers are generally working with SQL Server, but not always. And I know that probably since I did work with Oracle when I was working on my master's degree, but since then I have probably been on 2 or 3 projects where I had to query Oracle. Never as a database administrator, but just write queries against it. And, you know, luckily in today's world, we can just get online and, you know, I call it Bing or Google, to get the answers to these questions. Okay, so I meant, can you share an example of a package? I don't know if you can, because it would be proprietary to your company, probably.
Right. Yeah, I don't have a personal one handy right now. And yeah, Kathy, like you said, I couldn't share one from work.
Right, because it would be proprietary and she'd get in trouble. We don't want that. So, let's see. She said, okay, thanks. Yeah, so I was really, really excited to have you present for us tonight. Again, you do presentations from time to time, but this may have been the first time you've done for a group like this, so it's pretty exciting. And for our WIT chapter, we are all about helping people get to the next level. So I feel like we've enabled you to do that tonight, Ashwina.
Yes, thank you for the opportunity. Thank you so much.
Yep. Okay, so someone said, good job. So
thank you.
Okay, so I'm going to go ahead and close out if I don't see another question in about the next 10 seconds, and we'll get the recording out there. And Ashwina, if you wanted to send me your slides, I can post the slides as well.
I will.
Okay, well, thank you so much, and I will definitely be talking to you tomorrow. Well, maybe not tomorrow night, but I will be talking to you soon, Ashwina.
Sounds good. Thank
Okay,
you.
thanks. Bye.
Bye.